Welcome back. We got Randy kind of freaking out here on the chair. I wonder if he's gonna continue that. He is playing with a Q-tip. It looks like he's just carrying it around. All right, you keep doing you, buddy. We're gonna move on to page 2. Okay, we got a nice two-way table problem. I think this might be the trickiest part of this test, and so really pay attention to how this is going to be constructed. And so, let's see, we're starting out, Mr. Last, a big-time country fan. You and me both, Mr. Last. Wanted to poll his geometry students on whether or not they also enjoyed country music. Polled 30 males and 28 females. He knows that 12 of his male students like country music. Total of 26 students said that they dislike country music. Create and complete a two-way relative frequency table. So there's a lot of boxes here. This is just laid out. There's only 2 of these mutually exclusive facts in here, and so I'm going to put my male, female categories up here, right? And those, so on the top and the sides, they're always going to be mutually exclusive things, something that somebody cannot be both of. And so that somebody cannot like country and dislike country at the same time for our purposes in this problem. So that's where those are supposed to be. And then on these side columns, this is where your totals are going to go. Okay, I would like to lay out these totals. So, for instance, in this box right here, this is going to be all of the people, male and female, who like country music. And this one is all the people that dislike country music. Right here, this is the total people that are female, total people that are male. So we know some of this information. Let's put it in. 30 males, 28 females. So this is a total down here, 28 and 30. All right, this is called a two-way table because you can be a female in 2 ways. You can be a female by liking country. You can be a female by disliking country. So both of these boxes together should add to be 28. Both of these together should add to be 30. It's kind of like a summation table. You're adding things together. Let's see, 30 males, 28 females. 12 of his male students like country music. So male and like country, that's going to be 12. And a total of 26 students said they dislike country. So that's going to go over here, 26. The sum of everybody that dislikes country. Okay, so let's complete this table. The first thing I'm seeing is 12 males like country. There's 30 total. So then 18 must dislike country. And let's see, another thing. 26 people dislike country. 18 of them are male, meaning 8 of them must be female. Looks like our last thing here. 28 people are female in this class. 8 dislike country, so 20 of them must like country. And then let's get at the rest of our totals in here. Liking country, 12 and 20 is 32. And let's just get our overall total. And these should add together to be the same thing. 32 plus 26 and 30 plus 28. Well, wouldn't you know it? They both add together to be 58. Okay, so we got our two-way table completed. Now we can start working on these problems down here. What percentage of students like country music? Okay, and what percentage of students are female? So let's start with that country music one. So the probability that they like country, all we need to do is take those people that like country, all of them, just divided by everybody, because our sample space is everyone in this case. So 32 divided by 58 is going to give you a whopping 55.2%. So 55.2% of them like country music. And what percentage of students are female? So the probability that somebody is female, again, just taking the total amount of females divided by the total amount of everybody. So 28 divided by 58 is going to give us a 48.3%. Okay. And we might be using these later, so keep these in mind. I might be referencing them in these next couple problems. But given that a student likes country music, what is the probability that they are female? So we're looking for the probability of... Now, careful with this wording. It's actually the probability that someone is female given that they like country music. Okay, so since we're given that, now the formula for this is that probability of A given B And that equals the probability of A and B, that's what that little symbol is right there, divided by the probability of B. Okay, that's really saying on bottom are all the people that like country, or in this case, I'm going to use it as a percentage. And so I'm going to take that 55.2% from before. That's our new sample space. Since it's given that we know that this person likes country, so we know it's going to be one of these people, this 55.2% of people. And so that's our new denominator. That's the new thing that we're referencing. On top is the intersection of people that like country and are female. So these 20 people, and this ends up being 34.5%. So I got that from doing 20 divided by, 20 divided by 58. 34.5% of them. Right on top, probability that somebody likes country and is female. So 20 divided by 58 on bottom here. That's that number from before, the 32 divided by 58. And this would give us 62.5%. You could also do this by just doing 20 divided by 32, as this is your new total, 32 is. But you can do it with percentages as well. I'm going to do these with percentages. The answer key that I posted on Schoology shows you how to do it the other way too. Now let's look. Are the events of being a female and liking country music independent of each other? This is a question that's been coming up a little bit. The formula for that, if you want to show if something is independent, then the probability of A and B should be equal to the probability of A times the probability of B. This would show that they have no impact on each other. If these things are not equal, then they cannot be independent. If you can't remember what independence means or you need a little refresher, I put the math notes for it on Schoology as well in the folder, under the Chapter 10 folder. And so, using this formula, A and B in this case are the probability that somebody's female and likes country, and this should be equal to the probability of somebody being female times the probability that they like country. I heard somebody fall down just now. Some cat just fell off the counter. That's all right, I'll tend to them later. And luckily we know all these things from before, so that we got that 34.5%, that female and country from before, so 34.5%. And if this truly is, if these are independent, then this should be equal to that 55.2% times the 48.3%. And so if they really are independent, these will be equal, but it looks like 34.5% is not equal to the 26.7% you get when you multiply those two together. So they are not independent. Okay, that means that males and females have a different probability of liking country. So just because you know that somebody likes country, you don't have an equal chance of them being male or female, or vice versa, right? They impact each other a little bit. They're associated with each other. And we'll get to association a little bit later in this page. All right, moving on. At the University of Great Plains, the following data about engineering majors was collected. So we got a two-way table already laid out for us in this one. Now, conditional probability of living on campus given that you know a student is an engineering major. Okay, so another given, and so we need on top, on top part of our fraction should be people that live on campus and are engineering majors. So that's 120 people. And then on bottom should be, since it's given that they're an engineering major, the bottom is just all the engineering majors, which in this case is 920. So this is a little bit more simple of a way to do this, but this is really the same idea as what we did up here with the percentages. But now we're just using totals. Just wanted to show you a couple different ways that you can do this. So again, living on campus and being an engineering major, that 120, and just an engineering major. I'm taking this 120 divided by the 920, gives us about 13%. Okay, now are they associated? So these things are associated if they are not independent. Just a little thing to note about what association means. So really it's asking us the same question as C does up here. Are they associated with each other? So we need to show that same thing from before. Is the probability of on-campus living and being an engineering major, is that equal to the probability of campus living times the probability that somebody is an engineering major? So if those are equal to each other, then they are independent, therefore they are not associated. Okay, independent is not associated. So if they are not equal to each other, they will be associated. It's a little bit confusing. If you need a better explanation for that, I can always give that to you, and there's also some math notes on it as well. But we just need to show this fact and see what happens when we do this, and then we can talk about that. So the probability that they're on campus and an engineering major, that would be that 120 divided by 20,000. All right, living on campus probability, 120 out of the 20,000 people. Let's see if that is equal to probability that they live on campus, which is, live on campus and engineering, which is, let's see. So then just the probability that they live on campus. Okay, so that is the 12,000 people. Is this equal to the 12,000 over 20,000 times, and then the probability that they're an engineering major, that's those 920 people, so 920 over 20,000. This ends up being 0.6%. This ends up being 2.8%. So these are not equal to each other, therefore they are associated. Okay, they do impact each other, is really what that shows, since those are not equal to each other. Again, a little confusing, so if you need a better explanation, let me know. Either myself or a little Chanel right here can give you a better explanation. She just likes to be right on top of what is important. Classic.